All right, well, good afternoon, everyone. Welcome back to another exciting day in mathematics. Warm-up number 69 is on your screen. It reads, make a table of all possible outcomes that's using the spinner and tossing a coin. And then from there, just answer the question, what kind of probability is this? All right? I'll give you guys, 6 minutes, something like that? 5 minutes, 5 minutes, all right. Ready and go. All right, let's see. What kind of probability? Well, let's first answer the question in regards to the table. Let me hold on. All right, here we go. All right. Help us out, please. Zach. Okay, go. No, what was your table? Whoa. Okay, how did you make your table? Oh, okay. All right, help him out, please, Dom. Spinner. Okay, and then that's one column, or okay, going down or going horizontally? So you wrote R. What else? Okay, and then? Okay, coin. H and T for coin. All right, something like that. I mean, maybe not as nice as mine, but something like that. All right, continue from there. Eric, what do I do? Okay. HR, HB, HG, and HY, TR, TB, TG, and TY. All right. So, what are our probabilities? Pass someone, Eric. Oh, 1/8. Okay. So is it safe to say that all of them are 1/8, guys? Yeah. So 1/8, 1/8, 1/8, 1/8, 1/8, 1. How many of them? 8 of them. So at the end we need to get what? The probability of 1. Is that correct? All right. Tell you never what kind of probability is this. There's only 2 options so far. Let's see if you remember without looking at your notes. What are the only 2 probabilities that we've used so far? So let's see, what are the two probabilities, Andrew? Classical. And what is the other one? Cheney. All right, yes. So we got classical versus empirical. So which one did we just do now? Let's see if you understood from what we did last week. Hands if you say it's classical. Hands if you say it's empirical. It's classical because we didn't even try or spun or tossed anything. Empirical is through experience. Remember that we did with the die that I got you guys to do all that tossing and stuff? Yeah, that's empirical. But this one, when we don't even have anything done, we just come out with all the outcomes, that is the classical probability. Okay? Now, if I would have given you a coin and a spinner to spin, then what would that be? Through experience, so that would have been what? Empirical. Thank you, Mr. Q. You're welcome. All right, copy the agenda, please. Warm-up number 69. Intro to probability. And tonight's home play, it's not 15 and 16. It's actually 4-1. And the exercise is applying. And that section is right before the exercise at the end of the lesson. 4.1 or 4-1, applying what we learned. All right. So just a heads up, once again, grades are going out next week, so make sure you're all caught up and ready to go. All right. So last weekend's home play was 15 and 16. I mean Thursdays. So hold on to that. I'm going to plug that on Canvas. This is the applying the concepts where you're going to do at the end. So I'll shine that at the end so you can take a picture. Let's get a Cornell note ready, please. Today we're probably we'll be done with the introduction to probability. I only have one more exercise to do probably for tomorrow, and then we're done with this lesson. Then we're going to move on. So our objective for today, I can identify and compute basic probability. I can identify and compute basic probability. Once again, tell you what are the two types that we've seen so far. Yeah, very good. Classical and empirical. All right. So we started with probability, which says that it's the chance of an event occurring. And then we said that there's three types. There's classical, empirical, and subjective. We got into a formula for the classical, and we said that it was the number of outcomes for an event over the total number of outcomes. Then from there we went to empirical after we did some exercise with a die, and we came up with another formula, but now it's the frequency of the class divided by the total frequencies in the distribution. And we did that also last week. Well, today, and then we did our table for both. We went so that you guys can see the difference between the classical and the empirical. Today we're going to revisit, and we're going to visit now subjective probability. Okay? So at this time, I'm just going to ask you to relax, and I'm going to play a video for you. You just need to sit back and relax and watch the video. And then from there, we're going to talk about what you came up with and what you saw in the video. Okay? So put away your pods, your cell phones, or whatever it is you have. Let me play this, and I'll record this really quick. I'll pause the recording. 3, 2, 1. All right, for those of you that are following along with the video on the YouTube channel, we just saw a video of Jeremy Lin in his first game when he started his career with the New York Knicks. And through observation, each of you are going to give a probability as to what is the probability of making a basket or a pass. So you submit what you have. All right, here we go. So somebody put 100 basket, 0 pass. Okay. I'm assuming that's percentage. Okay. Basket, 40%. Okay. 60% basket, 40% pass. 11.5 basket and then 11.5 pass. All right. Half basket, 5/8 pass. Okay. 55 basket, 45 pass. 100 pass, 100 basket. 50-50. 70-30. 1/2, 3/4. 10-8. Okay. Basket and pass. Okay. He is more likely to pass the ball for an assist than shoot. Yeah, but what is the probability? Some numbers. Basket, 1 out of 3. Pass, 1 out of 2. Okay. Okay. 100% and 100%. Okay. 60% pass. 40% he shoots. Okay. So, let me ask you a question. Stop writing. What did I ask you to do? First, to watch the video, and then I asked you a question in regards to probability. Is that correct? What have you guys noticed with our numbers? What do you guys notice? Anything? They're not? They're not the same, number one. What else? They don't equal 1 or 100. How about, do some of them make sense? No. And it all is according to everyone's own observation. Is that correct? All right. What you just experienced, guys, what you guys just experienced is what we call, in probability, subjective probability. Does that make sense? And once again, I like for you guys to experience the actual probability so you guys can understand it. So let's make some notes. So I want you to write classical, empirical, and subjective. We're going to close this part, so we're done with this section. Okay. So what would you tell someone what is classical probability? What would you tell someone? Talk it over to your neighbor. What would you tell someone that classical probability is based on, or how do you get classical probability? And just to remind you, remember when we did the die for these two? Yes? Okay. All right. So, classical. Who went last? Was it Andrew? Shane, pick someone. What would you tell someone classical probability is? Or how do you get classical probability? Assuming outcomes? So, for example, I'm just going to write the example that we used. We put outcomes and stats, and we use the die example, 1, 2, 3, 4, 5, and 6. And what did we come up with? That each one of those has equal opportunity of coming up. So it would be 1 out of 6, 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 1 out of 6. According to that probability, it says that all have an equal amount of probabilities of coming up of 1 out of 6. So there's 6 outcomes, and it's 1 out of 6. Empirical. Outcome. And then 1, 2, 3, 4, 5, 6. Tell your neighbor what to write on the next column. They should remember for empirical. Mr. Q. All right, so what goes here? Andrew, pass someone. Shane. Right, so this one would be basing outcomes on experience. However, specifically what? How do we get the probability for this one? Who remembers? JC. Yes, F for frequency. For this one, we need the frequencies. We start tallying for each. You guys remember that? Yes? And so on and so forth. And then we come up with a probability using the frequencies. What did we use over here? Only the outcomes by the total number of outcomes. Over here, the frequency by the total number of frequencies. All right, and last but not least, subjective. Talk it over your neighbor, let them know what is subjective probability based on. Pass someone, JC? Jet. Based on people's view of data. So in other words, in parentheses, observational, comma, and not accurate. That one's usually the not accurate type of probability, which is sometimes, but you know what? At times it does come out. Like some of us, for example, there's going to be people that are let's say they work for a company and they find out patterns just by observing, and they're really good with patterns. Like raise your hand if you are one of those that are very good looking at patterns around the world. And I'm not talking about numbers. I'm talking about patterns. Anyone? Any one of you? Yeah, some of us? Or is it just me? That's weird. Yeah. Anyways, I see patterns, guys, everywhere. And I see things that repeat from time to time, and sometimes it comes up. Why? Because that's the way I see certain things. So sometimes they are what? Educated guesses. So that's the difference from one to the other and to the other. Okay? All right? So we're done with all three of those. I want to move on to the next part. And I'm going back to this one right here. Okay? So, again, copy that. And I'm going to focus on empirical today. All right? So this is what I want you to do. I want you to get in pairs again. And I want you to send a gopher to come get a die one more time. And we're going to focus right now on empirical. And this is what I want you to do. So you're going to have your own table. And then your partner is going to have the other table. And this is outcomes. 1, 2, 3, 4, 5, 6. Outcome. 1, 2, 3, 4, and then over here, frequency. But this time, you're going to have a die and your partner's going to have a die, so it can go a little bit faster. So this is what I want you to do. On the first try, I want you to toss the die. I want you only to toss it 9 times. And you're going to record your frequency. Then you're going to make another table. And for the next one, you're going to do, second try, you're going to do, let's do 24 times. And when you do the 24 times, I want you to combine your tallies with your partner's tally to only make 1 table out of both. All right? So die is over here. Let's get started, please. I'll give you guys some time. All right, I'm going to use Alejandro's data. Let's see. Go, Alejandro. For your 9 times, how many tallies for 1? How many? 3. How about for 2? 3. 4. 5. And 6. All right. And let's see, Andy, how about yours over here? Andrea? No, the 9 times, yeah. How many? Nothing, okay. All right. Okay. All right. So one thing to notice that once we try, according to the classical, we had what? We had outcomes, probability, and then we were 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. They were all 1 out of 6. But this doesn't look 1 out of 6, does it? Yeah. Sorry. This doesn't look 1 out of 6, nor this one. So, is everybody done with their 24 tosses? All right, let's see. Let me erase this over here, so like that I can get 24 tosses. All right, here it goes. Let's see, Vince. What'd you get? 6. 3. 3, 1. Okay. 4 for 4. 4 for 5. And 6 for 6. Now, if you notice here, look at this one. Look how we started here. 1, 1, none. And the only ones that looked like had more outcomes was number 1, 3, and 4. Look what's happening now with larger numbers. Aren't we evening up the data? 6, 6, 4, 4, 3. These two need to catch up. But what do you guys notice? You guys notice that this is catching up to start evening out? All right, so I want you to write this down. The more times you toss, or the more times you have frequency, the more it's going to align to a classical probability. Does that make sense? The more we're going to have an even amount of chances for each outcome. That's what we call, write this down, law of large numbers. Law of large numbers. So if I was to continue asking you to toss and then we combine all your tosses, guess what? Little by little, we're going to start seeing that all of them are going to almost be equally amount of probability for each of those. So just keep that in mind, okay? Law of large numbers. So lastly, take a picture of the home play for tonight. It's up on the screen. I want you to go through that exercise and see how you do, answer those questions, and bring that back tomorrow. Let's see how you do with all three probabilities and some of the terminology. Okay? I'll stop the video right there. You can log out. Enjoy. Bye.